Hi everyone, today's mini lesson is 1-7, ordered pairs. The first example, we're going to determine whether the ordered pair is a solution of y equals 3x plus 12. Just a little background information, there can be a lot of different ordered pairs that could be a solution to this equation. We are going to check each of the following three to see if they happen to be one of the ones that work. So the first one, we have 2, 19, where 2 would be the x, 19 would be the y. Because remember, our ordered pairs are written x, y. That's a good reminder. Now I'm going to substitute 2 in for the x and 19 in for the y. Remember I told you in an earlier lesson that you're going to put 2 in parentheses or whatever you're substituting in parentheses. That helps you know what operation to use next. 3 times 2 is 6. 6 plus 12 is 18. And does that equal the 19 that we substituted in for y? The answer is no. If the left and the right side are not equal, the ordered pair is not a solution. No. Let's check the next one. We're going to substitute 5 in for x and 27 in for y. So we have 3 times 5 plus 12. I'm going to go pretty quickly through these. 3 times 5 is 15. 15 plus 12 is 27, and when the left and the right side are equal to each other, that means that yes, the ordered pair 5, 27 is a solution. And let's check 115. So we have 15 in for y and 1 in for x. 3 times 1 is 3. 3 plus 12 is 15. And it also looks like 115 is an ordered pair that is a solution. So we had 2 of them that worked. You may have none of them that work. You may have 2 of them that work. It just depends on the question. And remember, there's going to be a lot of different answers that are possible solutions. In the next example, we're going to use the given values to make a table of solutions. So we're given the equation y equals 5x minus 1. And they're telling us to substitute in 1, 2, 3, and 4 for x. So we're going to start off with 1. 5 times 1 minus 1. 5 times 1 is 5. Minus 1 is 4. So our ordered pair for the first one would be 1, 4. We're creating a table set of solutions. Remember I told you earlier there can be a lot of numbers that are solutions. Let's try 2. If I substitute 2 in, 5 times 2 is 10. Minus 1 is 9. So we have 2, 9 is a solution. I'm going to try that with 3. 5 times 3 is 15. Minus 1 is going to be 14. So we have 3, 14. And then lastly, we're going to substitute 4 in. 5 times 4, 20. Minus 1, 19. So 4, 19 is a solution. What if we kept going? If we put in 5, 6, 7, 8, we could make an infinite table of solutions that would work given any sort of input that we put in there. So if we control the input, then we can write down whatever the output is subsequently. And then in example 3, we're going to write our own equation and define our variables. Safe is treating us to breakfast. Mini muffins cost $26 for a muffin tray, and each breakfast sandwich cost $4 per sandwich. To find variables, write an equation to find the total cost of the breakfast if 20 sandwiches are ordered. So I'm going to let S equal the number of sandwiches. You can pick any variable that you'd like. Okay. And the mini muffins cost $26, and we're only getting one of those trays. Plus, he's buying $4 per sandwich, and we're going to do C for the total cost of the breakfast. Now, it says 20 sandwiches are being ordered. So I'm going to substitute 20 in for the number of sandwiches. So 4 times 20 plus 26 equals the cost. And we're not substituting anything in for C because we don't know what the cost is yet of everything. That's what we have to find out. We follow our order of operations. 4 times 20 is 80, plus the cost of the mini muffins, which was $26, and we have $106 as the total cost. Make sure you label your answer because it's a word problem. And now I'm going to Chick-fil-A for breakfast. Have a great day. Bye.